take over.
Thank you very much. Let me get there, share. Let me know if you're seeing my screen.
Yes.
Okay. All right. Morning again, everyone. And I thought this would be a topic because it's so much in the news these days, in not just technology news, even the mainstream news or articles. There's a lot of references to AI, and both in terms of the fantastic things it may do or is doing, as well as more of a end of the world scenario about what may happen if the AI starts going against us and all of that. And of course, we've all watched movies probably over the decades, really, that have been about what could happen if machines are become intelligent or more intelligent than us. So the idea here is just to give a little bit more, I guess, and give some ground into all of the talk. What's hype, what's not, or what do we really know and predict will happen. And for full disclosure, I've worked in technology all my life, all my my professional life. Wouldn't consider myself an AI expert really in the technology field, but as you can imagine, well, working for Amazon as I have the last 3 years, there's been a very big push to make everybody more aware of what's coming or what's available here in terms of technology. Um, I was, to be honest, my initial thoughts were when AI became, the thing in the technology industry, that hey, I'm late in my career, I'll learn a little just general surface knowledge, but I really don't plan to get into it. But it's happened so fast that it's not almost, it's mandatory in my job now that we have to do a certain amount of AI training and start to incorporate it into our work. So that's just an idea of how much things have accelerated the last few years. But yeah, hopefully after this you'll have a little better understanding of some of these terms that are thrown about and what may or may not happen as a result of the rise of AI. So artificial intelligence really isn't a new thing in terms of the area of research, if you want to put it that way. And in fact, the term itself was coined back in the 1950s when Alan Turing, who was a famous mathematician, engineer type of guy, he came up with this what he called the Turing test, where he said, well, how do we know, how could we say if a machine is intelligent or not? Yes, it's faster than us in terms of adding up numbers. In those days, you had very basic like payrolls and such that the government and very large companies had, but most people, yeah, well, nobody had a personal computer. Most companies didn't have any computers either. But these guys were already imagining a world, after them that machines would become more quote unquote intelligent. So he was trying to define this or find some way of defining when would we say a machine is intelligent. And the Turing test was what he came up with, where he said, if you have, it's kind of a thought experiment where you say you have two rooms, you have this machine in one, and you have a human in the other. And you have a human or a tester, which would be a human, asking questions of both rooms. And didn't specify how this would be asked, whether it would be voice or it would be text or whatever it is, all of those things we have now. He didn't really have that, but essentially communicated with both. And his definition of an intelligent machine would be when the tester couldn't tell for sure which one was a machine and which one was a human. If it's at that point where guessing which one is which becomes about 50-50, then the basis of his test was that at that point we could consider the machine intelligent. And again, this was just his concept, which for a long time though did stand as a measure as machines got faster and we're training in artificial intelligence more to see how could they pass the Turing test or not. Well, it turns out very recently, this is actually an April 2025 article, ChatGPT, which is one of the technologies we hear about a lot these days, did pass this threshold that they set for the Turing test, where more than 75% of the people who they were essentially asking ChatGPT a question and asking a human a question. 75% of persons couldn't really tell the difference, and in fact, they thought the AI was human during a 5-minute conversation. So, in some aspect, we've passed what was initially defined as what makes a machine intelligent. But of course, there's a lot of development since then where people have said, well, the Turing test is a bit limited and such. But nonetheless, it's a fairly big moment in AI when a common, it's not any, this is a technology that's available to all of us now, is able to pass that test. So how did we get from there in the 1950s to where we are now? Well, it seems sometimes like it happened quickly because it's in the news a lot, but really this has been decades of research and development, and technology has improved itself. The hardware that technology that these software technology runs on. But essentially, I'm not going to spell out all of this. Just to summarize what you see on the screen here, as we said, the 1950s is when the Turing test came out, and when that term artificial intelligence was coined. And the 60s and 70s, it was really more of a academic and a research project. There wasn't really any commercial applications yet, but there were development of what were then called expert systems, which are very different from the AI we know today. But that was the initial area of AI that a lot of research was done in. In the 80s, some big institutions like banking started using them for things like determine if somebody is credit worthy or not. And the expert systems are basically just systems where there's a lot of rules, and the software looks at these rules and essentially compares someone's profile or some entity's profile against the rules and makes a statistical decision as to, yes or no kind of thing. So again, in banking, it may be if you want to give somebody a loan, some of these very large systems, when there were so many customers that a human couldn't do it all, it would say, okay, well, how many times have they missed pay? The things that we do for credit score today. How many times have they missed a payment? What is their salary? Maybe they'd look at some things like educational level, or, or future earning, and then make a decision as to whether this person is a good loan candidate or not. As you can imagine, even to today, there can be a lot of bias built into those rules. So it certainly wasn't perfect, both in terms of accuracy and fairness. But that was what was happening in those early systems. But it's really in the 1990s and coming forward to now that AI went away from this expert systems type of way of doing AI, or the branch of AI, and going into what we call today machine learning. So very often today, when people say AI or they say machine learning, they're kind of talking about the same thing, because machine learning is the main branch of modern artificial intelligence. Since then, though, you've had even machine learning has become more segmented, where you have what's called deep learning for certain types of applications. You have reinforcement learning for different type of applications and stuff like that. But really, they're all different branches of machine learning. And then more present day applications, this is what's very new since the ChatGPT era, is what's called generative artificial intelligence, which is a fancy term for saying artificial intelligence that can create new stuff. Because before, what AI used to be used for is like making decisions, like again, or recommendations. Like if you used to go on Amazon, or if you go on Amazon or any one of those big shopping e-commerce sites, it might do things like say, hey, you bought this and you bought this, so maybe you like this. And very often it's right. Again, that's machine learning type of AI, but it's not really creating anything new. It's just making decisions based on what it sees that you've done. With generative AI, it's creating new stuff. So we're seeing like the new AIs can create a video of people that don't exist, but they look like real people. They talk like real people. They essentially looks like a real video. They can make music. You can ask some of these new AI bots, hey, create a song like how Frank Sinatra would have made a song in the 1960s. And it creates a song which isn't any Frank Sinatra song, but it has the same style and it sounds like him and all of that, that's what's called generative AI, because it's generating it's being creative in a way that for a long time it was thought that AI couldn't really do that, but we are now seeing that it is able to accomplish that as well. One area that's been a good way of tracking how AI has got better, and this might be because I was a chess player in high school and played it for a long time, not as much now, but I still play it sometimes, is yeah, how much chess machines or chess playing machines have got better over the decades. When the first ones came out in the 60s, 70s, they were okay, but they couldn't really beat the top players. Even not even the grandmasters, but a very good chess player like a national champion or such. None of them could beat those. And I remember in high school, in fact, they had one or two that of those very early chess machines that used to play in tournaments, high school tournaments, and I couldn't beat them, but the best players at those high school tournaments in Jamaica could beat them. So they weren't that good, but they were fascinating. But within 15 years, in 1995, when IBM released its state of the art chess playing machine called Deep Blue, it was able to, within a year, beat the world champion at the time, Garry Kasparov, which again, it was a breakthrough moment for AI because chess is considered a game of, that requires intelligence. And I put that in quotes because, again, it's a little hard to define what that is, which we'll see. But it certainly requires a lot of brain work and, thinking through things and logic. And the fact that this computer was able to be better than anybody in the world. And today, you don't even need a Deep Blue. Pretty much any decent chess playing software can beat most players in the world, and a lot of the best ones can easily beat the world champions. So that has tracked how AI has developed. The early machines were using that expert systems type of approach, while the modern machines are using machine learning and some of the branches of machine learning, which is why they're so much better. Okay, so let's see if we can. This is just a bit of a test not a test, but an example of why AI has been taking so long. Well, I guess it could be long in terms of our lifetime, but why, I guess more specifically, why expert systems weren't very good at doing what machine learning is good at today. If I was to ask any one of you here, look at this picture and say, which one is the cat? And it's not a trick question. Obviously, well, you would say, well, the cat is the one on the left, right? If you ask a 5-year-old, probably, I'm sure most 5-year-olds, even if they can't read, never been to school, or even an adult who's never been educated in a formal sense, maybe not, not considered high IQ in any way. If you ask them which one is the cat, they could tell you. And what would be harder though, if you ask them, why is that one the cat and not the one? Why is the one on the left the cat and not the one on the right? That gets a little bit hard, and it's not something we think about much. But if somebody was to ask you, why is that one the cat and the other one is not a cat? You couldn't say it's because it's furry. You couldn't say it's because, it has 4 legs or a tail, or there's not too many things you could say to explain to, let's say, an alien who has never seen a cat and a dog before, or a dog before, which one is the cat and which one is the dog. Because it's just intuitive to us that we've seen enough cats and we know that the one on the left is a cat. That's not a great explanation, but it's really what it is. It's like we see it when we know it because we've seen hundreds of thousands of cats or whatever it is. So when we see another cat, we kind of know that we may not be 100% sure because you may have a very weird looking animal that looks like a cat, but pretty sure, 90, well over 90% chance that we know when we see a cat, we know that it's a cat. And that's what's called pattern matching in the artificial intelligence world, where humans, all of us, regardless of our status in life or education level or whatever, or which era we lived in, we are very good at pattern matching. When we've seen something many times, when we see it again, we kind of know that it's the same thing, or it falls in the same group. May not be exactly the same, but we have this intuitive idea that I've seen so many of these before. When I see another one, I know what it is. And that's something very specific to humans that has been very difficult to get machines to develop. So a machine is kind of like this alien who never seen a cat or a dog before, and you're trying to teach it what a cat looks like so that when it sees the picture of a cat, it knows it's a cat. So expert systems wasn't good at that because you couldn't really come up with all the rules easily for this example, or any example really. If you said, what makes a table, we've seen millions of, you can't just show it 2 tables and it knows that, every variation of a table is a table, the way we can as humans. So it was hard to put rules and expert systems needed to get to that level of identifying things and creating new content based on what it's seen before. That's where machine learning has been the breakthrough, where machine learning tries to do something closer to what we do as humans, where you use a lot of data of all types. Um, machine learning algorithms are their input is data. You're sending it email data, stocks if you're dealing with financial data, transactions, videos. If you're talking about identifying people and tagging people, you're talking pictures and videos. But all of that's fed into these machine learning algorithms, which are really a lot of maths and statistics. That's one of the things that surprised me as I've learned more about AI, is that it's less about IT and technology. It is that too, but the basis of it is really maths and statistics, linear regression and algebra and really deep math, which I did a little of in school. And when I see it come up now, my head hurts. But that's really what machine language is using on this data and then making predictions based on that. So even before the most recent craze about AI, even like maybe 10 years ago, again, if we were using our email and sometimes it marks some email as spam, that's actually machine learning doing that, where it's seen so much email that's spam, or you've tagged them as spam, saying if it says, you want to buy a new, this new ridiculous piece of equipment, or you want a free trip to Vegas, and you've marked them all as spam. When it sees another one come in and it looks kind of like that, it at least thinks it's spam and throws it in your spam folder. As you all know, it doesn't always get it right. Sometimes something that you really wanted to see goes in spam and you got to go look at it. But it's got a lot better. And the longer it sees your emails or the types of emails you get and what you consider spam, it's better at siphoning those out. Similarly, like again with recommendation systems, you bought these things, you like these things. Another place that machine learning have been used for a long time is with your credit card, like the fraud detection, where you get this, you usually are in this, in the US or in some other, countries that you travel to a lot. Suddenly, if you go to some country that you've never been to before and you're buying something that's unusual, you'll probably get a text or, a call saying, hey, this doesn't look like everything else you've done. So can you confirm that that's your transaction? Again, that's machine learning. It's saying, I know your patterns. This one falls outside of it. I think it's probably a fraudulent transaction or something like that. So machine learning is about that, feeding a lot of data, getting output. What they've learned though is that so far, the more data you give it, the better it gets. Just by giving it more, giving it more. So they've been you may hear the term training these AI models. The training is just finding data from wherever. Everything on the internet, if you want to train it about movies, you'll give it every movie you can find, and it understands how certain stars behave or whatever it is. But essentially, the reason so much money is spent on AI now is that the big companies have, at least for now, have found out that the more you can give it, the better the machine gets at making these AI type decisions and being creative about answering you as a human, as an AI person or AI chatbot than it did before. And the output of that is that we're getting all these new things like music composition. The images on the left are the new generative AI things, content creation, art, all of these things, which are creating their own controversies, but those are more than very new generative AI applications. The ones on the right are what we've seen, still machine learning, but what we've seen maybe over the last 20 years, where just in terms of businesses and interaction with e-commerce and such, we've seen a lot of AI taking place. But the generative AI is really what got people really excited in the last 2 to 3 years, and that's very new. But of course, all of this, with all the excitement, there's a lot of concerns in many different areas. This is by no means an exhaustive list, but I mentioned these because these come up a lot. Hallucination is this. Well, we know what it is for real people, but machine AI systems do sometimes they'll answer if I know you have had an experience even with ChatGPT or the others. Sometimes you ask it a question and it answers very confidently about something which is totally false. It made it up. It doesn't have well, I shouldn't say it doesn't have, but doesn't always tell you it doesn't know something. And that has caused problems in very many different areas. There have been stories about like lawyers using ChatGPT to say, give me some cases that, are about, let's say fraud or something, and it starts giving some famous cases, but somewhere in there it slips in a case about, something that happened in California in 1984 and a lot of detail which just did not exist. So that's what's called hallucination, and they're not quite sure why it does this sometimes. But it's a problem because it's very hard to differentiate when it's hallucinating from when it's giving you good data, which is most of the time. But you don't want to be using AI to diagnose you or to diagnose what kind of prescriptions you should get, and it just happen to hallucinate with you and give you something totally out there. So that's, of course, as you can see, there's some limits to what you can do as long as that's still a problem. There is fairness and bias, and that's where, because it's being trained on data, and data means like all the stuff on the internet that people have written or researched, some good, some bad, some biased, some not. But it's using all of that. It's being trained on all of that. So it will sometimes make a prediction or give information that's based on that bias, and not fair in terms of how we would, determine if something is fair or not. That's just in the data. As to how that can be solved so that you can identify what's fair, what's not, what's biased, not. That is not so easy. So it's something that is out there as a problem with the AI as it exists today. One of the big ones is energy consumption. These things use so much energy. The data centers that they're building, like the OpenAI and Google and all of those big guys, Amazon too, they use more energy than a small city does in terms of training these models on all this data that we spoke about. And because they're so anxious to stay ahead, they're throwing more and more resources at it, and of course it uses a lot more energy. So there's been questions about how far can this go before it becomes a bigger problem. And that's not even considering things like the climate change and the impact of traditional energy sources on climate change. This is just use of it versus using it for what we use it for today. And then there's copyright infringement, because and I think justifiably so, artists and people who have written a lot of content, whether it's creative content or even just writing articles, journalists. If this thing is trained on all of that data, and then now you're using that to say, hey, I don't need a journalist or I don't need a graphic artist, isn't that taking our thing and essentially stealing? And that's a big concern right now. There's actually been some legal cases against some of these large companies where, yeah, and again, I think rightfully so, there has to be some kind of mechanism to come up with to say, hey, if you're using, all the data on Substack or on Facebook or wherever you're getting it from, these are people's stuff that they're, either wrote or, they took those photos or whatever. There must be some way of compensating them, or something needs to happen there to model for that. So those are some of the big present concerns that we're seeing already today. There are also a lot of big ones that are expected to happen, although nobody quite knows how quickly. The more aggressive people think it's going to happen in 2 to 3 years. Others think it's a little bit further out. But these are some of them that are big concerns there. Massive workforce displacement, where we're saying if this thing can do all of the engineering work, it can do all of the predictions that an economist would make or something like that, or even like a doctor when they're diagnosing what's wrong with you. If it can do all of that, what are all these people going to do? And at the very pessimistic side of that, the feeling is that it's going to displace so many people that the whole economy will fall apart, or at least have a lot of problems. You'll have so many people not being able to work because this thing is working, which means everything breaks down in terms of how commerce works. There's privacy security concerns, of course, because this is already happening. In fact, some people are trying to use AI to spoof, to actually do interviews, or in college you're hearing about being used to well, that's not so much security or privacy, but people are using it for cheating generally, and of course the bad actors are using it to see how can they break into systems and all of that. That is expected to be much bigger as these things get better. And of course, the big one, which is I think the least understood, or there's a lot of divergence on what people expect or when they expect it, is what happens when these machines become super intelligent or they have general intelligence. And the next slide will explain what those mean a little more. But I think you can tell from super intelligence what that means. What does it mean when the machines are more intelligent than us? So this gentleman here, Eric Schmidt, was CEO of Google for many years. He's not anymore, but he works he invests a lot in this AI area, and he has he's very aggressive or very excited about what he thinks AI is going to do, even though he does admit that it's unpredictable. And he has about a 2-minute video here that I wanted to share because I think it explains a lot about someone who is in the industry. He's not this crazy person out there. He's worked, as I said, he's run Google, so he has insight into a lot of things. So let's see what he says.
We can't hear. I don't know if anyone else can hear the video.
No, no.
Oh, you're not hearing it?
No. Can you
Ooh.
share it with the video, like audio as well?
Well, let me see if I can do that. One sec. Let me get it. I'm playing it on my Oh, I think I know why. Okay. I may have to share it after, but let me tell you what he's saying. Because what I realized it might not be playing through as I expected it. But essentially what he's saying is that in the next 1 to 2 years, they expect that these AI systems will be as smart as the best mathematicians and the best engineers, and so will be competitive with people at PhD level, in terms of being able to do the work that they are doing. He also expects, though, that, or he's saying it's predicted in San Francisco and in those Silicon Valley type circles, that within 5 to 7 years, we'll have super intelligence, which is that the AI systems will be smarter than the sum of all humans, which means it's not just as smart as a smart guy, but it's so smart that even if you combine all of our knowledge together, it's smarter than that, which is a little bit scary. He thinks it can go either way, where if we all have this super intelligent thing on our phones, essentially, or at least accessible from our phones, that it can solve a lot of the world's problems that we can solve or will take us years or decades to solve, which makes sense. But the flip side of that is it can also, in the wrong hands, could be used for biological weapons. It could make virus. They could use it to make all kind of viruses and military machines that, again, no, maybe we do get to them eventually, but it's a lot slower, and governments and I guess the general population can react to that. So it feels like it's a case of how are these things managed. But I think his real position is that he doesn't think that as humans today, our society today, we're ready for it. We don't really understand how we're gonna what will that society look like, and how should we change our laws, change our just essentially how we work and how we live to react to that. And that's a big concern. And I think the governments of the world really haven't spent a lot. They've been excited about AI and what it may or may not do. But this whole idea that you'll have this thing that we don't know who's going to control it or all of that out there is definitely concerning and something that needs to be dealt with. No, I don't have a lot of time, but I'm almost wrapping up now. So the real question here as to what happens next is from a society perspective. We know it's going to do great things. AI is going to be used for great things that we'll all enjoy. But what is it going to do to our society? And that's where there are two possibilities. Maybe there's in between as well, but I'll give the two extremes. Agriculture 150 years ago, most of the world's workers worked in agriculture. They were, field hands mostly, but also overseers or whatever it is in agriculture. But 80 to 60 to 70% of the world's workers worked in agriculture. If you had told them then that in 100 years it would be less than 10% of the world's workers in agriculture, people would probably have said, well, where's the food going to come from? Who's going to create the food? We're all going to starve. There'll be all kind of thinking like that. Well, it didn't really turn out that way, because even though a lot less people work in agriculture, all of those people, and not them, but their descendants, have been doing all kinds of other things in the world that didn't exist back then. You have astronauts, and you have professional sports people, and you have content creators and influence, all of that stuff, as you know. So the fact that jobs go away doesn't mean that new jobs don't get created. And the more optimistic people think that AI is going to be just like that. It'll replace a lot of jobs, but it'll create jobs that we don't even know about today. But some people think that it's really different this time, because this thing is going to be smarter and faster than everybody else. And while we might see these graphs are showing different possibilities, the blue is kind of how we live now, where over years, people's wages gradually go up over the years. But the other two, which is if you have baseline AGI, or you have what's called aggressive AGI, which it happens really quickly, there's a lot of the people predicting these things are saying, well, we'll have jobs growth for a while and wage growth, but then it's going to just collapse when this thing gets to super intelligence. What does that mean for society? Again, we don't know, because we've been built on working, getting income and then spending it and all of that. If people aren't getting paid for work, well, how do they live? What do they buy? How do the people selling? All of that. Those questions which have no answers yet. And a lot of economics are doing work on what they're calling the post-labor economy, trying to model what will the world look like if we don't need many workers anymore. Very early in terms of that area of research, but it's something that, if this really does happen, has to be solved, or you're going to have a lot of social unrest and such. So that was, just an attempt to share some of the real concerns, some, pessimistic, optimistic projections, but certainly things that we should be aware of and thinking about as we go into this unknown world of AI and its prevalence in our society and in our daily lives, really. So with that said, maybe we went a little bit long, but we have maybe 5 minutes for a few questions if there are any.